Okay, so this is 12th CBSE physics. Magnetic field due to a current carrying circular loop at any point on the axis. On the axis of loop actually. Okay, circular loop. So I am Raju Roy here. I am having experience of 22, more than 22 years in fact. Because I started taking class right from 2000. I have been taking the classes. Okay, fine. So let us discuss about this magnetic field due to a current carrying loop at any point on the axis of what? Axis of the circular loop. Okay. So one thing you should remember, whenever we need to find the magnetic field due to a current carrying loop or current carrying conductor, we have to make use of Biot-Savart law. Biot-Savart law. Okay. What is this Biot-Savart law? The Biot-Savart law is like this. Biot-Savart law. This law says B is equal to mu 0 by 4 pi. This is it is the vector. Okay, I dl cross unit vector r. If I don't take the vector, if I take only the magnitude, I'll tell you about the direction. Okay, so because vector means it will have magnitude and direction, so direction we will discuss later. So let me make it the magnitude mod I am taking divided by r square. Okay, ideal is along the current. Okay, ideal vector is along the current. This dl vector is along the current, and r is nothing but that r cap, that unit vector r is the vector from the source to the point where we want to find out the magnetic field. Okay, suppose if this is the current I, this is your current I, okay, then ideal we have to take in this direction dl. Okay, actually this is I am finding for dl, no, it's elementary element, so dv better I will write. So ideal. Okay, so ideal direction will be this only, right? And here I want to find out the b, right? At this point p I want to find out the b. So from ideal you join this. From this ideal element, this is your I, this is your dl direction is in this direction, so this is your source. From source to p you join it. Okay, this will be along this direction, r cap will be there. So ideal cross r cap. Okay, got it. So this one, if you see, if we take this one, the ideal cross r, you will get by cross product, isn't it? By cross product I can find out the direction. Okay, so direction will be perpendicular to the plane which contains unit vector r and ideal. Okay, if unit vector is r in this direction, so r will be in this direction, same, isn't it? So unit vector means we are taking only the unit length along the r vector. Got it? So this is what the ideal cross r means. Okay, fine. So let us discuss about this the circular loop, no, current carrying circular loop. So let me draw the figure first. Okay, so this is on this plane. Suppose this is your x-axis and this one is your y-axis. Okay, better this is your y-axis. Better you show like this because I don't want to make the figure much complicated. This is your y-axis. So I am drawing as less as I can. Okay, fine. Now you see this is the loop lying on the xy plane. Okay, and so zx, this is your z axis, right? This is your z axis. P is lying from the center O. O to P is nothing but x. OP is equal to x. Okay, OP is equal to x distance, and this is the axis of the loop, that is current carrying circular loop, right? Okay, of the loop. OP is equal to x I am taking. Now what I have done here, I have taken one small elemental length dl. Okay, so dl will be what? Dl will be tangential or not? Dl will be tangential like this. Let me draw with another color. This will be tangential like this, right? This is your ideal vector, and current is going anti-clockwise direction. This is your anti-clockwise direction, the current is. Okay, now r is what? R is nothing but it is the distance from the, it is the vector actually. R is the vector which is directed from the source to the point where I want to find out the B, right? So this will be A to P, right? This will be A to P. Which color? Let me draw with green. Right? This will be your R. Unit vector R will also lie along this only, isn't it? So this is your unit vector R, or you can say R vector. Unit vector, when I say, then I am taking only the unit length, right? So this is your AP. AP is the R. So AP vector is your R vector, right? Now you see this is tangential, and AP vector and tangential vector ideal will be perpendicular to each other or not? Will be perpendicular to each other. It will be like this. Okay, this is perpendicular. So ideal cross R will be what? That is the unit cap R, unit vector R will be ideal into 1 into sine theta. Sine theta is how much? 90 degree. So it will give you ideal only, isn't it? Ideal cross R cap will be ideal. So let us use that. Then we'll go for this. So dV is equal to, so ideal is what? DL is a small, DL is a small element, current element, right? Current element. So dB due to ideal will be what? Means current element ideal, isn't it? This is a vector actually. DL is a vector. So by Biot-Savart law, dB is equal to, I am taking only the magnitude, okay? I am not taking the direction now, just magnitude. So mu 0 by 4 pi I dl into 1 into sine 90 or not, sine 90 degree, divided by the distance, that is R square. Okay, so now dV is equal to mu 0 by 4 pi ideal into 1 is nothing but ideal, divided by R square. Hope I am right. Let's see. Yes, R square. Fine. So this is your dV. Make it as equation number 1. Now I have drawn a model for this. Okay, let me show you if you can understand. Here you see, this is my loop I have drawn. Okay, this is the loop on XY plane. This is your X axis, this is your Y axis. Okay, and this is the, This is the axis, isn't it? This is the axis. This is the axis. Okay. See. And this is the point P. This is the point P. So you look here, this plane and the plane containing R vector. So DL to, this is your DL. DL to P point is the R vector and ideal. This is the plane. This is this white one. This is the plane which contains R unit, that is R vector, and this is the ideal, isn't it? This is the ideal current element, ideal. So this plane, if you use the ideal cross R, what will be? This is anti-clockwise direction, right? Ideal to R, when you go, it is anti-clockwise direction. So anti-clockwise direction, if you go, it will be perpendicular, because this is perpendicular. This will be lying. This dB will be ideal cross R will be perpendicular to this plane, which is nothing but this dB. This is the perpendicular to this plane or not? You see, this perpendicular to this plane, right? So dB will be perpendicular like this. I hope you are getting it, right? So this is what we can fine. So I have drawn here. Fine. So now what we are getting, at P it is perpendicular, right? At P it is perpendicular. dB is like this, perpendicular to AP. dB is perpendicular to AP. dB is perpendicular to AP. This dB is due to which element? Ideal element, right? So this is your dB. This is your dB. Now this is my 90 degree. This is your 90 degree, isn't it? Angle between AP and dB is 90 degree, because it is perpendicular to the plane which contains AP and ideal, which contains this AP and ideal, right? This plane, perpendicular to this plane, right? Fine. So this is 90 degree. Now let me tell this angle as theta. This angle as theta. So this dB can be resolved in along the axis, that is OP, along the axis OP. So that I'll call it as dB parallel. Okay. And another will be perpendicular to the axis, perpendicular, isn't it? So it will be like this, right? This perpendicular to the axis. So this is dB perpendicular. So what we will say, this dB, let us go to the next page. dB can be resolved along axis OP and perpendicular to axis OP, isn't it? Axis OP, right? So along OP, dB is dB parallel, right? dB parallel, perpendicular to OP, dB component is dB perpendicular, right? This is what I have taken. So this is your perpendicular, this is your dB, right? This is your dB, actual dB. Then we are resolving along this. This is your theta. So this is called dB parallel, and this will be perpendicular to this, isn't it? So dB perpendicular, and this angle is 90 degree, already we know by cross product, isn't it? So this will be perpendicular. Now you have this A here and P here. If I extend it like this is your center O, right? So AO is nothing but that is the radius R, and this distance is given in the question, that is x, right? This is your x. Fine. So dV parallel will be what? dV parallel is nothing but dV cos theta. dV cos theta. And dV perpendicular will be what? dV sin theta. Okay, dV cos theta and dV sin theta. Now dV cos, dV sin the perpendicular element, you see. See, this is your, okay, so this is your R, isn't it? This is your R. This is theta, this is 90 degree, and this should be how much? 90 minus of theta or not? Because total angle should be along a straight line, total angle will be 180 degree. So 90 minus of theta. 90 minus of theta plus 90 plus theta will give you 180 degree, right? So if this is 90 minus of theta, this is 90 degree already. So this will be theta or not? This will be theta. So we can say cos theta is equal to, okay, one thing we can say, one more thing before going to cos theta. R is what? R is nothing but root over R square plus of X square. Both R and X are given in the question, right? So that means R I can write in this form, right? In terms of capital R and X. Now cos theta is equal to what? Cos theta is adjacent by hypotenuse, right? So R value is this. Fine. So cos theta we have got. Now regarding sin theta. For sin theta, before going to sin theta, let me tell you one more point here. If you analyze it, see, this is my loop, right? This is the loop which is carrying current I. This carrying current I, and we have taken this element, this dl element, right, along with this I. Direction is in this direction, which is tangential, right? This is ideal, right? This point A. Don't write much, otherwise it will be complicated. Now just opposite to this, I can take dl here, right? So that will be in this direction. Ideal will be in this direction. By symmetry we can say here for this element we have, this is dB, okay, and for the second element, let me change the color of this. For this element, exactly opposite, okay, exactly diametrically opposite, exactly opposite. So D will be in this direction or not? Same angle it will be, right? dB will be in this direction. Magnitude and direction, everything, just direction will be opposite, right? If this is theta, then this is also theta, right? And you see dV parallel for this and dV parallel for this, both will be acting in this direction, isn't it? And dV perpendicular will be acting in this direction, dV perpendicular, right? And this dV perpendicular, both will have same magnitude but opposite direction. So what will happen? They will cancel out each other. This will cancel this one. So only component remaining is the dV parallel, right? Only component is the dV parallel. So how can we write this? So dV perpendicular cancel out each other due to symmetry, right? Due to symmetry. Fine. So only element remaining is dV cos theta. Okay. So dV parallel is equal to mu 0 by 4 pi ideal by r square into cos theta. Cos theta just now we have found r by small r. Small r is nothing but root over r square plus of x square. Fine. R square plus of x square. So in order to find the whole B due to this small elemental, no, I can take a small length like this everywhere, isn't it? And add up together, which is equivalent to integration, isn't it? So dB is equal to integral dB parallel, because dB perpendicular is not taking part. Why it is not taking part in this to find the B? No, it is not contributing anything in the B, because this is getting cancelled. Here I have explained, right? So due to symmetry, this gets cancelled out. Okay, fine. So dB parallel. So take out all the constant terms. So mu 0 by 4 pi, I is also constant, R is also constant, root over R square plus of X square, right? So only variable is dl, so we will L, isn't it? So if we integrate this dl, what we will be getting? We will be getting the circumference, right? So mu 0, circumference of the loop, 4 pi IR divided by, okay, yeah, here R square we have left, no? Cos theta R square. So this will give you 3 by 2 actually, isn't it? Here this will give you 3 by 2. Look here, R square, and this is R, isn't it? So R is per cube, that is R is per 3 by 2. Hope you are getting it right. R square will be R square plus of X square, right? And already into root is there, so that will give you 3 by 2, 1.5 power will be. So R square plus of X square whole raised to the power 3 by 2. And dl, just now I told you that if you integrate it throughout the loop, you will get the circumference, which is nothing but 2 pi capital R, because this radius is capital R, right? So 2 pi capital R. So this gives me 2 pi get cancelled, 2 pi and 4 pi will give you 2. So mu 0 by 2 I R square divided by R square plus X square whole raised to the power 3 by 2. So this is your B. Okay, this is your magnitude. And direction will be what? If suppose if it is lying in the xy plane, here I think I have done, no, I have told xy plane, no? Yes, it is lying on the xy plane. So what you have to do? You have to use the right hand thumb rule. What we do? You curl your finger, right hand, curl your finger along the direction of current. Okay, see, current is anti-clockwise direction. The stretched out thumb will give you the direction of B. Okay, so this is the direction of B. So this will be along Z axis, right? Z axis. So for our case, it is along Z axis. If you take XY, YZ plane, then it will be along the X direction. Okay, X direction. It can be positive, it can be negative. That depends upon the direction of the current. Okay, just make use of this. Curl your finger along the current direction, and then the stretched out thumb will give you, that is right hand thumb. Okay, that will give you the direction of B. So this is your B. So if I am taking XY plane, then here it will be what? Direction will be, I can say, K cap, isn't it? So this is your vector. Got it? So hope you have understood. Yes. Thank you.